Okay, welcome back to this session. Here we are going to see another topic, flow and level measurement. Flow and level both I am combining here. So here, as you know, you could have studied about fluid properties and all in fluid mechanics subject. So here, there are two types of flows, laminar flow and turbulent flow. So it is actually decided by the Reynolds number. You could have studied about Reynolds equation, PVD by nu, where P is the density of the fluid, V is the velocity flow, D is diameter of pipe, nu is dynamic viscosity of fluid. Where Reynolds number, if it is less than 2000, the flow is known as viscous or laminar. When Reynolds number is greater than 4000, the flow is turbulent. When Reynolds number is between 2000 and 4000, then it is a transition flow. So here, these are the three types and the three ways we can divide this. So to measure flow, there are so many devices available. The first one is orifice meter. So orifice meter, it is nothing but just orifice plate which is kept in between the flow. So here the flow is in here, and we have the differential flow can be measured here using a manometer, and it is this setup is known as orifice meter, and you have this is the flow pattern and flow out. So it is placed in between a pipe. So this orifice meter is kept in between a pipe, and next one is same orifice meter. You can see here, this is the orifice, the circular one. In its side view, you can see this is 45-degree plus or minus 2-degree inclination slant shape. You can see here. It is just like conical shape, and then you have a continuous the hole here, and when the flow is coming here inside here, then it passes through this orifice meter. So there this flow can be measured through this path, and this is the eccentric orifice plate. So instead of placing at the center, it is placed at the end at this place, and from center to here, the center of orifice meter and center of this pipe, you can see there is a eccentricity between these two centers. So this is orifice meter. So in a simple way, this is another shape of segmental orifice plate. So this is another shape of orifice plate, and you can see quadrant edge orifice plate. So these are all the configurations of our orifice plates. So here you can see the orifice plate. It is the quadrant edge orifice plate. So this is inside view. It is clear how it is shaped. And another one to measure the flow is venturi meter. It is a very popular device. So here this is the venturi. So this is venturi meter, and this is the pipe, and the pipe is converged like this. So this is known as convergent cone, and this is known as divergent cone. So in between you have throat, and the same manometer is used here to measure the flow, and this is the another setup to measure flow. The rotameter, it is also known as variable area flow meter. So here directly the rotameter gives the flow rate. A device used to measure fluid flow in which a float rises in a tapered vertical tube to a height dependent on the rate of flow through the tube. So that is here inlet and outlet. So you have directly a scale, and this can be measured. like this, and you can see the structure of rotometer is like this. This is the float. So when the flow comes inside the rotometer, the float will go up, so due to buoyancy force, and the float will come down due to gravity. And this is the inlet and this is the outlet, and this is directly measured, direct measurement method for flow measurement. Next one is pitot tube. So this is the pitot tube, and pitot tube is L-shaped tube which is kept against the flow. So here liquid in and liquid out, and this pitot tube, the difference in heads between the piezometer and the pitot tube, that gives you the flow in this given pipe. So this is another arrangement, and pitot tube using these parameters, this can be calculated using Bernoulli's equation. So applying this Bernoulli's equation between point S and point P in the undistributed flow at the same horizontal plane, we get this is the flow rate, and this is the Hs, and this is V, and V is the velocity at point P, free flow velocity. It is known as free flow velocity, and P naught by W plus V square by 2G equal to Ps by W. So here where Hs is equal to this small equation, and this derivation and all not required for our syllabus. And P naught is the pressure at point P. This is known as static pressure. Ps is stagnation pressure at point S, and delta H is dynamic pressure. G is difference between stagnation pressure head and static pressure head. So in previous diagram you could have seen static Hs and H naught. So next is level measurement. There are many methods for the measurement of liquid level, which can be categorized as follows: direct sensing, in which the actual level is monitored; indirect sensing, in which a property of the fluid, such as pressure, is sensed to determine the liquid level; single point measurement. So here these are the three methods: direct sensing, indirect sensing, and single point measurement, in which it is only necessary to detect the presence or absence of a liquid at a specific level. So these are the three methods. So in direct level sensing, the direct level sensing methods are sight glass, float sensors, ultrasonic sensors. So here this is the sight glass. So here the sight glass are visual observation of liquid levels. So here you can see the tank which is filled with liquid, and the sight glass is fixed here using two valves, two shut-off valves. The sight glass or gauge is the simplest method for direct visual reading. So it is by viewing the liquid level, we can say it is the level can be determined here. So sight glass is a very simple method, where visual method where directly you can see, and say the sight glass is normally mounted vertically adjacent to the container. The liquid level then can be observed directly in the sight glass. The ends of the glass are connected to the top and bottom of the tank via shut-off valves. Glass gauges are cheap but easily broken and should not be used with hazardous liquid. Next one is float sensor. The float material is less dense than density of the liquid and floats up and down on the top of the material being measured. The float sensor is accurate and have a linear output with height level height. However, if the surface of the material being monitored is turbulent, the float reading may vary excessively. Some means of damping might be required, such as stilling well. So here you can see this is the float sensor. By float is made to float on this liquid, and that is measured here using linear scale. So in still well arrangement, you can see in this diagram. Next, ultrasonic level gauge. Ultrasonic or sonic devices can be used for a single point or continuous level measurement of liquid or a solid. A setup for continuous measurement is shown here. So here this is the fill edge, and this is known as hull edge, and this is transmitted sound. So from ultrasonic sensor, the sound is transmitted to the liquid, and from liquid it will be reflected, and that will be received by the sensor. So this is the ultrasonic level sensing. So, a pulse of sonic waves, it is approximately 10 kilohertz, or ultrasonic waves more than 20 kilohertz from the transmitter is reflected from the surface of the liquid to the receiver, and the time for the echo to reach the receiver is measured. The time delay gives the distance from the transmitter and receiver to the surface of the liquid, from which the liquid level can be calculated. So knowing the velocity of ultrasonic waves, so it is approximately 340 meters per second. Since there is no contact with the liquid, this method can be used for solids and corrosive and volatile liquids also. Sonic and ultrasonic devices are reliable, accurate, and cost effective. However, vibration or high noise levels can affect the devices. So that is the another drawback in this. Indirect level sensing. In these methods, a property such as pressure, weight, capacitance, or resistance are measured first and from which the level is calculated. It is indirect level, and methods are pressure level gauge, displacer gauge, capacitive level gauge, Doppler devices, resistive tapes, load cells. These are all indirect methods. And this is pressure level gauge. So here by measuring pressure, it is possible to see the level. Pressure is often used as an indirect method of measuring liquid levels. As shown, a differential pressure sensor can replace the sight glass. So it is very similar to sight glass method, but here a differential pressure. So this is the pressure level gauge, and this is pressure level gauge, and this is pressure gauge. So differential pressure, using this differential pressure between these two areas, it can be measured. So the hydrostatic pressure at the bottom of the container increases as the depth increases in a fluid. The pressure is given by P equal to P GH, rho GH, it is rho GH, and where PIS is the pressure, P is the pressure, rho is the density, G is the gravitational acceleration, and H is the depth. So here this is not P, it is rho, and this is P. P is the pressure, rho is the density, G is the gravitational acceleration, and H is the depth. Hence, the level can be explorated from the pressure and the density of the liquid using this type of indirect method. So displacer gauge. So here a displacer is placed. This is the displacer. According to the Archimedes principle of buoyancy, the buoyant force on the cylindrical float displacer. So this is the displacer kept in the liquid, on the liquid, and using this Archimedes principle of buoyancy, it works. Is proportional to the volume of immersed in the liquid. The higher the level of the liquid, the higher the buoyant force. So using buoyant force, it is measured. The apparent weight as seen by the force sensor strain gauge is equal to the weight of displacer minus the buoyant force. There is only a small movement in this type of sensor compared to the movement of the float sensor. Displacers are simple, reliable, and accurate. The liquid must not rise above the top of the displacer, and the displacer must not touch the bottom of the container. So these are the constraints which are there always when we are using displacer. So using buoyancy principle, it works. And capacitive probes. So this is the capacitive probe, is kept in the liquid, and this is how it is measured. And this is air. This is the outer shell of the probe, and this is vessel, inner rod of the probe. The capacitive probes can be used for continuous level measurement. The capacitance is the function of dielectric material between the two plates. So this is how the capacitor probes are also used here. The capacitive probes, materials placed between the plates of a capacitor increase the capacity of the factor known as the dielectric constant of the material. For instance, air has a dielectric constant of 1, and water has dielectric constant of 80. In the portion of the probe that is out of the liquid, the air serves as the dielectric between the rod and outer shell. In this section of the probe immersed in the liquid, the dielectric is that of the liquid, which causes a large capacitive charge change. So that change is directly proportional to the level of the liquid and can be measured using an AC bridge circuit. The dielectric constant of the liquid must be known for this type of measurement. Another one is bubbler device. So here the gas bubbles are used to measure the level. The bubbler devices require a supply of clean air or inert gas to prevent interaction with the liquid. Gas from the pressure regulator is forced through a tube via flow regulator, and the open end of the tube is close to the bottom of the tank. The pressure required to force the liquid out of the tube is equal to the pressure at the end of the tube due to the liquid, which is depth of the liquid multiplied by the specific weight of the liquid, that is rho g. So that is here the bubbler devices are used in this way to measure the level. So next is resistive tapes. Here, resistive materials are used like capacitive probes. A resistive element is placed in close proximity to a conductive strip is an easily compressible non-conductive sheath. The pressure of the liquid pushes the conductive strip against the resistive element, shorting out a length of the resistive element that is proportional to the depth of the liquid. The sensor can be used in corrosive liquids or slurries. It is cheap but is not rugged or accurate. So here the capacitance probe, the sorry resistive strips or resistive tapes are used like this to measure the liquid level also like this. Next is a strain gauge load cell. So load cell here here this is the platform on which the weight acts. This is the cylinder on which the strain gauges are mounted. Three strain gauges are mounted here. The weight of a tank of liquid can be used to as a measure of the liquid height of the liquid in the tank. Load cells are commonly used for such weight measurements. Typically, a load cell consists of a strain gauged cylinder, which is included in the supports of the tank of the liquid. When the level of the liquid changes, the weight of the load cell changes, and the resistance of the gauges change as well. The resistance changes of the strain gauge are thus the measure of the level of the liquid. Since the load cells are completely isolated from the liquid, the method used for corrosive liquids. So, strain gauge working principle already we have discussed in earlier units. So, in the same way, the strain gauges are employed to measure the liquid level. So single point sensing. Single point sensing is used in on-off applications. Two of the methods for single point sensing are conductive probes, beam breaking probes. So first one is conductive probes. So here the conductive probes are used in liquids that are conductive and non-volatile since a spark can occur. Two or more probes can be used to indicate set levels when the liquid is in contact with two probes. The voltage between the probes because of because probes causes a current to flow, indicating that a set level has been reached. Thus, probes can be used to indicate when the liquid level is low and when to operate a pump to fill the container. So here, this is the uh, 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 probe. Probes are used, and one probe is shorter like this. Another probe is immersed in the liquid, and these are the probes here with variable lengths. You can see here. A third probe can be used to indicate when the tank is full and to turn off the filling pump. The use of AC voltages is normally preferred to use of DC voltages to prevent electrolysis of the probes. So here the probes are immersed in the liquid, so the electrolysis also possible, which can take place in this process. So beam breaking methods. Beam breaking methods are sometimes used to pressurized containers. It is a single point and a multi-point. So here this is a single point, and these are multi-point sources, and this is beam breaking methods. So here the beam breaking methods are like this. For single point measurement, only one transmitter and one detector are required. The beams can be light, sonic, or ultrasonic waves or radiation. The devices are low cost but can be affected by deposits. If several single point levels are required, a detector will be required for each level measurement. The disadvantage of radiation based beam breaking systems are the cost and the need to handle radioactive material. However, this system can be used with the corrosive or very hot liquids. High pressure containers are used where conditions would be determined to the installation of other types of level sensors. So there ends the flow on level sensors. We will see in the next session, students. Thank you. We stop here, and we will see in the next session. Thank you.